Let's conduct the data analysis. So I have to come to this bar where we have the file, edit if you have to edit, view the way that you have to do the data view or variable view. Then we have to transform if we have any other data to transform here. Then we come to the analyze section. Then we have a chart builder where we can chart graphs. We can choose the graphs to draw. For example, if we have the divorce status, then we have to use this chart. So we can select this to be in the x-axis so that we have count on the y-axis. So that is plotting a chart. Then we can have extensions if you have any and all that. So I'm coming to analyze reports, or this I have to go to the descriptive statistics and analyze the frequencies. Then I have to analyze the frequencies for divorce, for whether the couples are black or not black. Then is the husband black, are the couples mixed, and also the duration they have had, higher education. Then I click this arrow to move to this variable view. Then I check for the any of these variables that may need or any of these that may need to be checked. For example, the mean, the median, the mode, the sum, and all that. So here, because we are using discrete data, I'm not going to check any of this. So I click OK and click display frequency tables. Then the charts, I'll use the pie charts. Instead of displaying frequencies, I'll display percentages. Click continue, then click OK. So it comes to this output sheet or the output document, and shortly it will show all the graphs, all the presentations that are needed. So we also come to analyze the descriptive statistics. Let's say the descriptives, and for the descriptives you're going to use the years in marriage. Then the options, you have to click the mean, the sum, the standard deviation, minimum, maximum, standard error, if there's any need to calculate the variance, the skewness and kurtosis if you may need them. All those can be calculated here, so that we have the descriptive statistics according to what you're doing. Then you click OK. After doing that, we come to the output view, find that it has finished computing all that we needed for the data set. For example, the general statistics, we have the duration, the husband achieved higher education. Now the statistics, we have valid entries 3371. Is the husband black? Valid entries are 3371, and so forth until the divorce status. We have no missing values for each of these variables. Now we come now the duration, husband has achieved higher education. Less than 12 years, we have 1288. 12 to 15 years, we have 1655 husbands. More than 16 years, we have 428 husbands. The percentages are displayed in this section. The valid percentages are also displayed in this section, which are similar. Then the cumulative percentages is 35 plus 38 plus 49, we have 87, then plus 12.7, we have 100. 22% race. Checking if we have mixed ethnicities in the marriages. Those that are married for mixed ethnicities, we have 19%, while those that are of the same ethnicity are 81%. The divorce status, the divorced are 30%, while the censored are. Then we have the pie charts. When you double click the pie charts, you click on this section to show the data labels. and close, then close. Same to this, you double click it and click on the labels section. So we have the, oh, this one we've not labeled it. Yeah, now we have labels for all the charts, or all, yes, all the pie charts. So for the descriptive statistics, the years in marriage that we've just conducted, the total is 3371, the minimum is 0.079 years in marriage, the maximum is 73 years in marriage, the sum is 62,060 years in marriage, the mean is 18 years in marriage, the standard deviation is 14.9, the skewness is 0.965, the standard error of the skewness is 0.042, the kurtosis is 0.110. The skewness and kurtosis are essential in finding the normality of the distribution, as I will explain later. Now we move to the next section. The next section of the analysis, let's say as we had been studying earlier, we go and check, we have checked the descriptive statistics and the frequency analysis. Now we check the reliability of the data. Reliability of the data is checked using Cronbach alpha. A high Cronbach alpha indicates that the data is reliable, while a low Cronbach alpha indicates that the data is not reliable, hence data collection has to be conducted again. So we come to analyze, you move to scale and go to reliability analysis. And we have to check the reliability of all the variables together. So you move to this item section, and we may need to check what is making the data not reliable. That's why I have to click on scale if item is deleted. Otherwise, it's not compulsory. And you may need also to check the means and all this analysis. You may use also the ANOVA, checking the hypothesis tests and the regression tests. You may also check the correlations and covariances if you need to check them all at once. Therefore, you click continue and you click alpha. We have to check alpha and click OK. So what we are finding is the summary. It gives you a summary of what you've done, and the reliability is 0.025. This is too low. Reliability tests should give you a minimum Cronbach alpha of 0.7. Below 0.7, the data is not reliable, hence a new data collection has to be conducted. However, if the reliability is above 0.7, the data is reliable and you can progress with the analysis. Checking on what is affecting this, that is why I selected Cronbach alpha. If the item is deleted, you find that the divorce status has a Cronbach alpha of negative 0.02. This is completely unacceptable. And only years in marriage are considerable high, 0.305, meaning the whole data set is not reliable. However, I'll create a new video to indicate where data was reliable so that you can see and also make informed decision making. Not good for analysis. However, for the purpose of tutorials and for the purpose of helping you understand how to use SPSS, I will progress to the next section. So the next section, as I will show you, is conducting the normality tests. And two types of normality tests are common in SPSS. The first is the Kolmogorov-Smirnov test, and the second is the Shapiro-Wilk test. The Kolmogorov-Smirnov test is conducted when the data is more than 100 respondents, when all the variables, all the respondents in the data are more than 100, while the Shapiro-Wilk test is used when the number of respondents is less than 100. So our respondents, as we will see, were higher than 100. They were 3031. So we are going to use the Kolmogov's man of tests. So we come to analyze, then we go to descriptive statistics and explore. In exploring, we move the variables to the dependent list. Divorce is the factor list. You move this to this section, while this, let's just move all to the dependent list and check for the normality, or to check whether the data is normally distributed or not normally distributed. So the statistics, we're going to check the descriptives only. We may also check the outliers. Click continue. Then the plots, we're going to check for the let's leave the stem and leaf plots, otherwise, although it is also necessary, but what we need most is normality plots with tests. Then leave the other sections as they are. We are using dependence, so dependence have to be factored together. That's when if we are going to use the box plots, then click continue. Then we need both statistics and plots. So we click OK. So SPSS is conducting the analysis in the background. And this is what we have. Because we selected descriptive statistics, it conducted the descriptive stats for each of the variables that we were testing. So this is the case summary. These are the descriptive statistics. What we need most is this test of normality. We can find that the Kolmogov's man of statistic is 0.267, 0.48, 0.496, 0.11, 0.441, while for Shapiro-Wilk test, the statistic is 0.783 and all this and all this. But since the values were higher than, since the degrees of freedom are at 371, which is very high, we're going to use the Kolmogov's Smirnov test. What is important here is to check the sig value, to check whether the output, the statistic output that we found is significant. And as I was conducting the test, the level of confidence was 5%, or it was at 95% confidence interval. Therefore, this sig value has to be either lower than 0.05 or higher than 0.05. If this value is higher than 0.05, it means that it is not statistically significant. Therefore, the data is normally distributed. However, since this value is lower than 0.05, we find that this data is statistically significant and it is not normally distributed. It is statistically significant, hence it is not normally distributed. We can confirm this by checking the expected normal plots. We find that the expected normal plots is this line, this trend line. However, the trends are going up and down in a curved state. And let's check using the trended normal. You find that for the deviation from normal, there is this line where we have the normal. However, we have some deviations from the normal, which is at 0.1 and also at 2. There's a deviation from the normal. Also, we have this deviation from the normal and also this. Also, we have now this, which is the number of years in marriage. You find that if it had been normal, it would be consistent with this line. However, since it is not normally distributed, it is given by almost a curve, meaning that most of the values are lower than 40. Most of the values that we're checking are lower than 40. When we checked the skewness, we found that it is 0.965. It is tending towards the lower side. Therefore, our findings indicate that this is towards the lower side, towards the left. So most of the variables are aligned towards the left. Also, for the divorce status, it is not normally distributed. It's either 1 or a 2. And here we have the box plots indicating that there are some outliers in each of the variables, as indicated here, because we have these values that are outside the box plots. Okay, the normality tests have shown us that the data is not normally distributed. Welcome to the next video that we may understand more about the correlation analysis.